talk to you about OpenFaaS, which is a serverless framework for Docker and Kubernetes. So it's a little bit different to what we've been looking at so far from the cloud vendors. Okay? I'm going to tell you what serverless is, how it can be used, and what you can do with it. I'm actually going to give you some demos with Alexa up here as well. Okay, so when we think about serverless, what we're really looking at is an evolution in how we build our applications. You see, we used to build these big, slow, monolithic applications. They're very hard to release and deploy. They involved a lot of effort. They did so many things at the same time. We then broke those down into microservices, and they had much more constrained responsibilities. They did less things. We could move faster. Ops was actually a bit easier. And they were smaller, so they were easier to deploy. Now, when we look at functions, we're really thinking about the next step in that evolution. We're getting even smaller. Now, your serverless function does one thing and does it really well. Okay? So we're looking at breaking things down even more. Typically, we'll take a response, produce some output, and once we've deployed it, we can pretty much forget about it. Okay? So some of the use cases for serverless might be to basically deploy a function. Okay, let me move on. So a key use case for serverless in the industry would be the Amazon Echo Dot, which we have up on the stage just here. How that works is we speak to it, just like this. Our voice is uploaded to a cloud, and then a monolithic application will parse what we said into some JSON. That JSON will then be sent to a Lambda function. And notice that the Lambda function will use another monolith or microservice. Actually, it's using another backend to get weather information. Once we've got the weather information, that comes back and produces some speech. Okay? And then that will be basically said to us from Alexa, and I'll just show you how that works.
In Milan, Italy, it's 68 degrees with partly sunny skies. You can expect more of the same today, with a high of 73 degrees and a low of 55 degrees.
Okay, so that was an example of how a Lambda skill works with Alexa. We'll just put her back on mute. But you can actually replace that Lambda function for OpenFaaS, okay, and Docker containers. But why would that matter? Well, you should be able to run your code for however long you want, not just 5 minutes. And I know from speaking to people here that that's actually a problem that you have right now. You should be able to run it wherever you like and not be constrained and locked into one platform, and using whatever skills you already have in your teams and your companies, okay? Which may not be Linux-based functions, right? It could be .NET, it could be Java. Now, I did a little bit of a function, serverless function, and I've been recording all of the tweets. That's why Alex asked you to keep tweeting earlier. Now, if you want to tweet something with hashtag serverless, Alexa might actually read it out in a second. So if you've got your phone, you can try tweeting something. But first of all, I'm going to ask her one question. Alexa, how many tweets?
Sorry, I'm not sure.
Alexa, ask Twitter how many tweets we've had.
There have been 363 tweets about serverless today.
Okay, and so if anybody's actually tweeted, she's probably going to read it out now. Alexa, ask Twitter what the latest tweet was.
RT at Vanelop. My slides today at hashtag JeffConf serverless beyond functions hashtag serverless hashtag AWS.
So I'm not sure if you had enough hashtags in that one. But if you want to see the code for that, it's actually it's in the repo, it's in the notes at the end. And so that's an example of actually running Alexa skills on top of Docker Swarm in this instance, on your own hardware. Right. Now, there are a few driving factors behind OpenFaaS. It's not actually the only open source project that does serverless. There are actually a few out there. But some of the driving factors are that this is really for developers. Okay, so it's not just for people who are already experts with containers. Now, what that means is that you can deploy OpenFaaS in 60 seconds with one line script. Just go to the repository, clone it, and you can deploy it pretty much instantaneously. There's a UI built in, so you can see what functions you have and how to use them. We'll also focus on portability. Now that's important, particularly if you're in the enterprise world and you want to avoid, as I saw in the advanced topics over here, vendor lock-in. Okay? You need to be able to move between providers and use something that looks pretty much the same wherever you go. You can also deploy this on your laptop. So maybe as you're going home away from the conference, you might want to give it a run through, about 60 seconds. Okay? Now, it's radically simple, and that's what's driven a lot of the adoption and a lot of the interest. Okay? We're not trying to reinvent the wheel. We're actually using existing technology to create something very simple. Okay? So once your function is deployed, we're using existing orchestration technologies to scale it, to create fault tolerance, and to do all the things that you'd expect from a distributed system. And then finally, it's an open platform. So we have a Docker Swarm backend, a Kubernetes backend, Rancher, and Alberto somewhere here came up to me and showed me how he implemented DCOS for OpenFaaS. And that just gives you more and more options of where you can deploy it. Now, I just got this through before I flew out. InfoWorld voted OpenFaaS as one of the best projects of 2017 for the cloud and open source. And it's incredibly exciting to be grouped together with Docker and Kubernetes and Terraform, but it's been a lot of hard work, and it's great to see this. Now, I want to tell you a bit about the story of why I built this. So I started off, like many of you here, looking at a Lambda function for Alexa. Now, I didn't want to just run it on Amazon's cloud and pay them money for it. I'm sorry. And I was a Docker captain as well, and a Docker captain is someone who is pushing the boundaries of containers. So I thought, this is just Node.js. I can run this in a container, and it's really easy. So that was my first project, was to try that out. And then I heard about the DockerCon Cool Hacks contest. If you won, you got to present to 5,000 people in America. It was a big experience. So I said, well, what do I need to do? And they said, just push Docker beyond the boundaries of what it was designed to do. And it wasn't easy, so I had to try many times, and eventually I won this contest and I presented, and it was incredible. But there's been a lot of changes since then. You can see from this graph that we've actually had almost 6,000 GitHub stars already. It's been the top trending project on GitHub over all the projects for about a day. Okay, that's above Go itself. It was ridiculous, and I don't know how it happened. We have Kubernetes support now. Many people have been hearing that maybe Kubernetes is the winner in the container race. Okay, I think there's room for other platforms as well, but we have support for it now, first-class support. We can do asynchronous processing too, and we have a CLI that goes back to that developer-first experience. So if you've used a serverless framework, you get the same kind of YAML format that you can play with. Now we have 33 authors on GitHub, and that's going up every day. 160 people in our Slack community, almost 900 commits, okay? And they're not all mine. They're from all of these guys, okay? And we actually have John sitting in the front row, my wife, and they've really helped the project as well. And it's kind of when the community rallies round and they catch something of what serverless is and they get excited, they keep building and building and building. You wake up every day and somebody's done something you just never expect. And that's one of the reasons why I'd love you to come and be part of this project too. You can find out a bit more about that later. So what can you do with serverless? Well, I know we've heard a few ideas so far. Some people put some kind of limits and boundaries on it. I'd say anything that can run in a container can run as an OpenFaaS function. Literally anything. But if we put some constraints around it, maybe we could say machine learning. Okay? I'm going to show you an example of machine learning where I've been able to package TensorFlow as a function, and we'll look at whether we can work out what's in an image. Batch jobs are very important for a company like ADP, where I currently work. We process something like 10% of all payrolls in North America. There's a lot of payrolls, a lot of batch jobs. Okay? And batch jobs are probably like the prototype serverless function, okay, going way back. Image and video conversion. So Someone said about when serverless emerged, well, actually, there was a project called Mantra at Joyent, and that was kind of a pre-Lambda implementation. And they said the highest workload they had was converting images and videos. And that is still important today. And I'm going to show you how you can do that with FaaS. Mobile backends like Alexa are perfect, and then chatbots and chat operations. As we automate more of our mundane, repetitive tasks, we can actually let the computer do the work for us and link that with machine learning. Now, HTTP services are just your regular APIs. You can build them as serverless functions and get them to production quicker. Okay. Now, when I say that OpenFaaS is basically a serverless framework for containers, what that means is that every piece is a container. Okay. I don't know how many people are familiar with Docker, but that's the format that's being used here. Okay. So one of the developer evangelists at HashiCorp, when he went and presented about this, said, you just deploy 2 containers and you can use all the existing tools you've already invested in. Okay, so if you're using containers, it's not a big step to start using OpenFaaS. When we come to manage those functions, we don't do it ourselves because it's a solved problem. We actually use Kubernetes or Docker Swarm and let that scale the functions for us, let that pick where to put them on different hosts, let that evict functions that are misbehaving. Okay, and there's actually quite a rich ecosystem around that. Docker Enterprise Edition exists for companies like ADP that gives them content trust. It allows them to scan images for vulnerabilities, and you can do things that you just couldn't if you're locked down into a certain runtime. Okay. Now, some of us have probably heard that you can write in different programming languages. Okay, you can be a polyglot. But I spoke to the VP of Engineering at ADP, and I said, look, why don't we write them in Ruby? And he said, because I know how to support .NET 4.5 on Windows in production, so that's what we should use. Because when I get a call at 3 a.m., I want to know that I can sort this problem out. Okay. So with OpenFaaS, you can actually write your code in .NET on Windows and run it as a serverless function if that's what you want to do, full .NET. Okay. Some of you that are consulting with enterprise clients, that might be really important for you. Okay. Now, yeah, avoiding vendor locking is quite clear. And I've heard that is a bit of a problem. Now, when you come to run serverless functions on your own, so when you come to deal with confidential data, it's even more important, okay, to run your code where the data already is. An example of that would be payroll. Okay, so who likes to get paid? Who likes to get paid by work? Lavoro? Dinero? Yes? So this is Docker's mascot, Gordon the turtle, and he actually loves FaaS. He had a second job, a second lavoro for me on Twitter, and this is what he did, and I think he deserves some money. He deserves a cash bonus. Okay, so the bonus is a bit of extra money for him for the work. So before I do that, I want to find out how much my payroll will cost. I'm going to ask over here. Alexa, ask my assistant how much my payroll will cost.
Your payroll will cost $105 for this period.
Okay, so I think I can afford a bit of a bonus. Okay. Alexa, ask my assistant to award bonus to Gordon.
Your payroll will cost $105 for this period.
Alexa, ask my assistant pay a bonus to Gordon.
Pay them how much bonus?
$500.
Let me process that for you now. Your payroll will cost an additional $500.
And we'll just see how much that is in total. Alexa, ask my assistant how much my payroll will cost.
Your payroll will cost $605 for this period.
So that sounds right, doesn't it? Where we had the base number and the bonus, and it's all worked. But how did that actually work behind the scenes? Well, we've heard about step functions. Well, here's 2 serverless functions. They're both actually written in Node.js, and one of them is a payroll function, What that does is that acts as the Alexa skill, just like you'd write for Lambda. It's pretty much the exact same code. We deploy that. That deals with the voice. And then as we talk to it, it's updating values in an S3 bucket with the numbers, and then Payroll just adds them together. Okay. Now I'll tell you a little bit about the internals, about the overall stack of OpenFaaS. It's a Golang project. Now you may see the API gateway up there. That is not the one that you know from Amazon. Okay, it's a new one. And every function you deploy gets its own unique route there. So immediately when you deploy a function, you can already access it. When we invoke the function, it will go through to the function watchdog. Now that's a tiny binary that sits inside every function and just makes any code into a serverless function. Then underpinning that is Prometheus Metrics. Prometheus is a standard way in the industry to measure how applications are being used. So it's a bit like CloudWatch. Okay, we can see how quickly it's being used, and then we can auto-scale it. So as people call it more, we'll scale it up. And then Docker and Swarm, or Kubernetes, allow us to give you that same experience you may be used to, where your application looks after itself. We talked about maintenance of machines. Well, you can just delete a VM and add more later, and your work will spread out. So a little bit about the function watchdog. This is what sits inside every container that you make as a function. How it works is your request comes in over HTTP via the gateway. So the gateway is like a load balancer. We read the request body in and the headers. We fork your process and invoke it. We then read back the response over HTTP. Now what that means is that literally anything can be a function, even something that never knew about functions. So ImageMagick can become a native function. Cat, the command cat in Unix, can become an echo function really, really quickly. So you may be wondering, well, if you fork a process for every request, what's the performance like? Well, with something like Python or Golang, it doesn't really matter. It's very, very fast, a few milliseconds. But if you come to Java, and I know when you have enterprise applications, that's particularly important, they're slower. But we can tune it up. And so with some basic tuning, we've gone from 100 requests per second on a commodity VM to over 3,000. So it's pretty quick. So it's probably enough about the project. Let's look at a quick demo. What I'm going to do is open up a terminal, and we will log into a host I have. Now what I'm going to do is a one-line command. This is a Kubernetes command, and I'm just going to run in these services. And there's documentation for this, so you'll be able to get hold of it from the README file. All of these will be run in, and then within a few seconds, we'll see the API gateway has appeared. And down the left-hand side of the screen, we can see all of the functions that are already part of the stack. If we want to, we can deploy a new function really quickly just by typing in some details here. We can also use a CLI. So what I'll show you now is our CLI. So I have a bunch of samples here. And what I'm going to do is, I'm first of all going to delete them. John changed the name of that recently. And as they get deleted, I'm just removing them from the cluster. And what we'll see is they'll just drop off this list. Okay. And then as soon as they're gone, I can just redeploy them again. And so you could imagine that you were sitting at the office and you've just created a new function, you've deployed it, they're already showing up in the UI, and we'll take a look at one. So this one is actually just using a binary that's already in Linux called SHA-SUM. Now if I type something in here like my secret, hit invoke, I'm going to get a SHA-SUM generated. And I could invoke that through curl, I could invoke that on the command line. Also got some node applications here that I want to show you too. So why don't we take a look at one of the famous kind of examples, which is to resize an image. So what I'll do, first of all, is I'm just going to remove the older one, the smaller image, and I'll show you what we're going to be working with. It's a picture of a toy monkey. And you see what's happening is we're invoking the function, we're then piping the result into a file, and as we open that, we get the smaller monkey out the other end. Now, I didn't actually have to write any code for that, and I think that's one of the important distinctions here, is I just took an existing binary that was in Linux, and I said, that's my function. And because it works through standard in and standard out, the old Unix way, we can make anything a function, not just Node.js, okay? Now, what about a real-life example? So over on the project, we have a lot of admin to cope with. A lot of people, all those 33 authors are coming and trying to make changes. Now, has anybody ever done a pull request on GitHub? Yep, okay, great. So we have a contribution guide, and I'm not going to read it. I'm just going to create a patch, but I'm not going to read the contribution guide. So here's my pull request. Forget about the checklist. And here it is. But what's this? Derek, the robot's come along, serverless function. He said, actually, you haven't done it right. You didn't read the list, and I've checked it. And he's telling me what I need to do to fix it. And as soon as I fix it, he will take the label off, and then I can merge the pull request. So I've been able to automate for some of the flaws that are in GitHub's API. Now, you may have seen this thread yourself. It's very hard to give granular permissions to a particular person in a project. You kind of have to give them full write access. Now, that Derek robot, he can allow me to check that someone's signed off all the data they need to for every commit. We can assign issues to different people, and he will also manage the labels. So John, for instance, has access, and he can type in Derek, add this label. And because he's in the maintainers file, the serverless function will run, check the file. If he's in it, he'll then allow the label to be added. Okay. So that's an example of how we're using it in the real world. And that's something that I think can also help us at ADP with our work every day, deploying and releasing code to production. There's one other function I'm going to show you really quickly before we just move on, which is if we go back to the machine learning theme, and we take this picture of a whale. Now I have a function here, which is called categorize or inception, and it's using a catalog of images. So what I can do here is put a URL and invoke it this way. And it should just come back and tell us what it thinks is in the picture. So it thinks there's a sea lion in there. It thinks there might be a great white shark. It thinks there's a killer whale. Okay? So we've been able to use a machine learning algorithm there. This is a serverless function. I've deployed it on OpenFaaS, and I can get a result back on an image really quickly. Okay? What's kind of interesting is if you take a picture of a toy whale and you put it through the same catalog, it comes up with something very different. So let's give that a quick shot. So this is the toy whale, and as you can see, it's got some really strange ideas as to what that is. Now, imagine that you have a requirement to recognize text as part of one of your products, as part of a pipeline, OCR, or you're scanning documents. You can take your existing binaries and code, package them up in this way, deploy them on OpenFaaS, and then start using them in a pipeline of functions. Okay? And in this instance, the computer was actually smarter than we were, because I'm sure we all thought that was a whale. Computer knows better. So when you come to build your own serverless function, things look a bit like this, just like you're used to with Lambda. We have the handler up on the top, and any requirements you need, we write in a request text file, or maybe in a package JSON. So in this example, I can create a brand new function by typing in FaaS CLI new, put the language name, and then the name of the function I want to create. I can then build that and deploy it to my OpenFaaS really quickly. So the time between creating the function and deploying it is a few seconds, and you start to access it. I don't think we've got quite enough time to look at that now, so we might just skip past it. But in terms of what programming language is supported, given this model of using a template that will create a Docker image that can be deployed, we have supported templates for .NET, Python, Node.js, and Ruby. But if there's something you need to get into a function which we don't have a template for, you can just use a Docker file. So if you've already got code that uses a Docker file, you're not far from deploying it as a serverless function. Once you start to get a few functions together that are logically grouped, it's kind of hard to manage that, right? And some of you might have seen the Serverless Inc. project, where you can define a YAML file and say, these are my functions, they work together. So in the same way, OpenFaaS has that, and here we have a Python function which will ping a URL and tell you what the HTTP code is. And then underneath it, we have the shrink image that I demonstrated earlier, and you'll see that actually under the fork process, just there, the third line, the second chunk, this is convert from the input to 50% less, and then pipe that out through standard out. So it's just literally using a binary. I didn't write any code, which I think is kind of cool. We can then build and deploy those using the YAML file. So it's developer friendly. So one of the other key use cases for this is to be able to scale on demand. So let's say we have 6,000 files to copy from the West Coast to the East Coast in an S3 bucket. And for every file that gets copied, we want to have an audit trail so that we can say, okay, they all got there in time. But as that function gets called more and more, we need to cope with the load, so we will scale it. So I'm going to show you that live in action. So we'll just kick off the transfer now, and all those files are starting to copy across. So with OpenFaaS, we have a dashboard that's built into the application. And what that does, it allows us to see how our functions are being called, how frequently, and how long they're taking. And in a second, what we'll see on the right-hand side is that the scaling of our function that's receiving those files is going to go from 1 replica to 5. And if we keep going, it's going to go from 5 to 10, 10 to 20, etc. And so we're able to cope with even more load. So we've just seen that work there. We've now got 5 replicas. And as soon as that transfer is finished, the replicas will go back to 1 again. So that's auto-scaling up and down automatically. So just a quick note to say that we have Kubernetes support, and this is basically it's going to open up a lot of doors for you, especially if you don't like managing your own infrastructure. You can deploy into something like Google Container Cloud, and I think Alex has just given us time here. But what I would do is upload these slides, and you can get hold of them and start to play with it, kick the tires. All right? Thanks.